Good morning, children. Now I am in my second video of set theory. So let us start without spoiling time. So we were discussing types of sets. So now one type of set is singleton set. Singleton set is a set which contains only one element. A set which contains only one element is called a singleton set. That is, set A is one set, only A is here. Suppose B is set of all x such that x is an even prime number. X is an even prime number. So what you will get? In this case, you will get it only 2. So this is singleton set. Now pair sets. A set containing two elements is called a pair set. That is A, suppose A is a set, two elements are 1, 2. B is a set, B is set of all x such that x square equal to A. Now again this is in the set product form. So x square is equal to A. That means what should the value of x? That value of x should be minus A plus A, because only minus A square is equal to A and A square is equal to A. So we have written minus A comma A. This is called paired sets. Now equal sets, children. Two sets A and B are said to be equal, written as A equal to B if every element of A is in B or vice versa. That is, all elements of set A is in set B and all elements of set B is in set A. So let A is set element 1, 2, 5, 6. B is set and having elements 5, 6, 2, 1. We say that both sets have same elements. Maybe order may be different, and order is not having any impact on set. So set A is equal to set B. Second example is A is the set of all x such that x is the letter of the word loyal. X is the letter of the word loyal. So what happens? And second, B is the set of all x such that x is the letter of the word loyal. So here A is writing it in a table form, L, O, Y, A, because L is repeated. So L, O, Y are the distinct letter of the loyal. And alloy, A double L, O, Y, A, L, again it is repeated, we will leave it, O, Y. So here A equal to B, A equal to B. Both sets are equal. Now next is equivalent set. Two sets A and B are equivalent if their cardinal number are same. If their cardinal number are same. Cardinal number means number of elements in a given set A is called its cardinal number. Let A is equal to A, B, C, D. B is equal to 1, 2, 3, 4. Here number of elements in set A is equal to how much? 4. Number of elements in set B is equal to 4. Since their cardinal numbers are same, that means A and B are equivalent sets. So in equivalent set, we are only concerned with number of elements. What is given as an element, we don't bother. Now, most important topic is subset. Now, we will discuss, children, subset. So, what is subset? So, when we are talking about subset, that means we are taking two sets A and B. So, if each and every element of set A is also an element of set B, that means all elements of set A is contained in set B, then A is called subset of B and it is read as A is subset of B. This is the sign of subset. So A is equal to 1 to 4, 1, 2, 4. B is equal to 1, 2, 3, 4 and P is equal to 1, 2, 4, 5. Here A belongs to P. A belongs to P, but B do not belongs to P. A belongs to P. That means because 1 to 4 elements of set A is 1, 2, 4 and P is 1, 2, 4, 5. That means all elements of A is contained in P. We can say that A is subset of P. But B is not subset of P. Why? Because 3 belongs to B, but 3 do not belongs to P. And according to definition of subset, set A is subset of B when every element of set A is contained in set B. Here also A is subset of B. A is subset of B. Yes, 1, 2, 4, 1, 2, 3, 4. That means all elements of A lies in set B. So how we write it? Let us understand it. If A and B are two sets, similarly we will write X belongs to A implies X belongs to B. Then A is subset of B. X belongs to A implies X belongs to B. We will say that A is subset of B. Suppose A is equal to 1, 2, 3. Let us understand it. Then X may be equal to 1 or 2 or 3. Let B equal to 1, 2, 3, 4. That then X may be equal to 1 or X is equal to 2 or X equal to 3 or X equal to 4. Here 1, 2, 3, all the three values of A, all the three elements of A, 1, 2, 3 is in B. That means A is subset of B. So we do not belongs where 4 belongs to B. That is not none concerned. We are just focusing our attention that 1, 2, 3 is present in B or not. So we can say that if X belongs to A implies X belongs to B, then A is subset of B. Now some theorems on subset. That is null set phi is subset of every set. Why null set phi is subset of every set? Because suppose null set phi is not subset of a given set A. That means what? There must be some element in null set which is not in A. But according to definition of null set, a set having no any element. So our assumption is wrong. So null set is subset of every set. Secondly regarding subsets, if a set has n elements, then it has 2 raised to the power n subsets. 2 raised to the power n subsets. It is we calculate it by binomial coefficient formula, that is nc0 plus nc1 plus nc2 plus dash 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 ncn is equal to 2 raised to the power n. nc0 means number of combination of 0 things taking n at a time, number of combination of n things taking 0 at a time. nc1 means number of combinations of n things taken 1 at a time, like this. It will go till number of combinations of n thing taking n at a time is equal to 2 raised to the power n. Now if A is equal to 1, 2, 3, then what is number of elements in A is equal to 3. So number of subsets is equal to 2 raised to power 3, that is 8. So subsets are, first start for no elements 5 the subset of every set. Now for one element, one set 1, 2, only two will lies, that is singleton 2, singleton 3, and pairwise taking 2 at a time, 1, 2, 2, 3, 1, 3, and last ncn, that is how in which way you can select 3 things taking 3 at a time. So this is how many? Only one way, that is 1, 2, 3. So this is the arrangement of finding the subsets of a given set. Had it been 4 elements, number of subsets would have been 16. So now third is, if A is subset of B, B is subset of C, and C, then it implies A is subset of C. A is subset of B, B is subset of C, implies A is subset of C. Let X is an element of A, that is A, X belongs to A. Since A is subset of B, what does it mean from the definition of subset? X belongs to A implies X belongs to B, hence X belongs to B. Again, B is subset of C, implies since X belongs to B, implies X belongs to C. So can we write X belongs to A implies X belongs to C, hence A is subset of C. So this is one of the most important theorem, that if A is subset of B, B is subset of C, implies A is subset of C. Every set is subset of itself. Abnorm. Thirdly, fourth is every set is subset of itself. Set A is subset of itself because all the elements of set A is contained in set A. So we can say that every set is subset of itself. These are the 4 points, it is 4 results related with subset. These are very important. Okay, thank you.